Hello and welcome back to Nature of Code with Rust and GGEZ. It's been a while since I've last recorded, but we're going to be moving on to example 1.2, bouncing ball with p-vectors. Well, we're not going to use p-vectors here because that's like a processing vector. We're going to create our own vector because I want to show some interesting things that we can do with traits that are going to give us the really cool abilities that we want to have with vectors that we can't have in processing. For example, they show that what we want to be able to do is have this location plus velocity equals our new location, that we can't do that with p-vectors. But I'm going to show how we actually can do that. So let's go ahead. I've copied over the example 1.1. So if we run this again, we get the exact same example. I've just updated the title. So the first thing that we're going to do is we're going to come in and under utilities, I want to create an actual vector. Let's create a vector struct and have it like do all its stuff. Now I know that they're using the p-vector class that's provided for them in processing. No such structure is available to us in Rust. Now, that being said, there are plenty of libraries that we can use, like NAlgebra is an example that I've used quite a bit in the past. It's an excellent linear algebra library, and it has lots of matrices type data structures that we can use, for example, vectors. But we're going to create our own in order to make sure that we understand and know the math of vectors and what we're going to be doing with them, but also to show off how we can do some cool stuff in Rust that we wouldn't get if we didn't implement this ourselves. So I'm going to actually create a struct here. So let's do a pub struct, and we're going to call this a vector. I'm going to call this a vector 2 because it's a two-dimensional vector, x and y. In the future, if we ever need a three-dimensional vector, then it would be x, y, and z, and that would be a vector 3. There can never be a vector 1. A single number is actually called a scalar. All right, so we're going to have an x, which now in our cases, they're going to be F32s, but it would be fairly trivial for us to use generics here, where we could say x and y are something else. For right now, let's stay with the F32s, and if we have a need for it, we can switch over and start using generics. All right, so we're going to do an implementation for the vector 2. And we're going to create our constructor, and we'll just take in the x as an F32 and a y as an F32, and return a self. All right, simple enough for this. And we can now start using this everywhere we want to in order to, wherever we need to use this. So let's go find in our main library where we're actually using this. So to begin with, we have this x and a y. That's our, well, this should be a location. So I'm going to go ahead and say this is now going to be a location, and that's going to be a vector 2. I want that from the utilities. Let's go ahead and close that too. Now we have this speed x and speed y. So I'm going to make this I'm going to call this a velocity. And you're also a vector 2. And I don't think we need anything else here. We're just going to replace the x and y directly in our main state with this location and velocity. For new here, okay, coming down, here's our x and a y, so it's 100, 100 to start off with. So we're going to start with let location equals vector 2 new 100, 0, 100.0. And then speed, we have this 1.0 and 3.3. Let's go ahead and update that. Let velocity equals vector 2 new 1.0 3.3. And then in here we'll store location and velocity. Okay, good so far. Now, when we have our update here, we want to say, okay, so self.x, so our location, our x location is increased by the speed location here. Well, we could write this as self.location.x plus equals self.velocity.x. Like that's an actual very valid way of doing this. Now we have x and y as private right here. We may have to deal with that in a little bit, but what we really want to do is what we saw up here. We want to be able to just take our location and add it to velocity. So if I wanted to do that and say self.location is equal to location self.location plus self.velocity, we'll notice that we get an error saying cannot add vector 2 to a vector 2. An implementation of add might be missing for it. So we can actually implement that ourselves. Let's implement. So impl add. So it's a standard ops add for a vector 2. And then we're going to implement our missing members. So we need add here. Okay, so we get a right-hand side. That's a self. There's another vector 2. And we're going to, it's going to be a new, we're going to take ownership coming in. And we're going to create a new one here. So we're just going to create a new self with, let's see, what is that going to be? That's going to be our self.x plus right-hand side dot x. Self.y. This is x is self.x plus right-hand side. This is y is self.y plus right-hand side dot y. And type, let's see, output, provide a definition for the type. So I think we can just say, can I just say there's no type here and it's just self? Can I do that? Oh, missing output. So I need output. Oh, type output equals type. That's what we need. So type output equals, and that's going to be a vector 2. And so we can do self output. So it's going to be basically we're exporting a vector 2. All right, so we're creating a new self from here and setting what this will be. So back to this, we notice that this works now. So we have location plus that. Okay, perfect. We get our width and our height. Now this entire thing needs to be, we need to like figure this out where we have, okay, so if self.x, so wherever we have a self.x, even if it's a self.y too, it doesn't really matter here. Each of these is going to be dot location. So if self.location y, if we're less than 0, then set your location. Oh, but then this is going to be the velocity. So velocity dot x. This is fine there. Now we do have to set, you have to be public, both of these. And, okay, so coming down, location at x is greater than width, location, okay, and then you are also a velocity. Then we do the exact same thing. You're going to be a velocity.y, velocity.y. And coming down to a bottom, we have, Okay, so this is where we get to have a little bit of fun here. We have this destination, which needs to be an array of X and Y. Well, we don't have to, like, we could also create functions off of this vector that help us out here. So maybe we can create a function called toArray, which takes in a reference to self. We don't want to take ownership of it. And we're going to return an array of F32, and there's 2 items. So in this case, we're going to return self.x, self.y. And because of that, I don't have to get x and y directly. I can now call self.location.toArray. Okay, that's happy there. What do we have here? All right, what are you upset about? Cannot move out of self.location, which is behind a mutable reference. Move occurs. Okay, so, which does not implement the copy trait. So we could fix that. Let's implement copy for vector 2. So we're going to derive. Debug is probably fine, so we can print that out if we need to. But we need clone and copy. And then everything is really happy here. No problems. Size is not being used. Why are we not using size? Where's our mesh? We have our mesh being created here. Radius is size. Oh, I guess we're not actually using the size for this, are we? Because we're using the center. So we could just remove that. It doesn't really matter. Okay, no errors, no warnings. Let's go ahead and see if this still works. Cargo run this, and the ball still bounces around. Okay, perfect. Now there's one other, sort of bonus thing that we can do here. What if we don't want it to be like this verbose even? Like, what if we want it to be a little bit more condensed? Well, where we can have self.location plus equals self.velocity. That would be a lot easier to type. However, when we hover over this, it says, hey, we can't do this. Add a sign is missing. Okay, well, we can just go and add that too. So we're going to do an impl of add a sign for a vector 2. Implement. Add a sign is a little bit easier than add. It's just this function, add a sign. We take a mutable reference to self and our right-hand side, and it's going to mutate the self. So we're going to say self.x plus equals right-hand side dot x. Self.y plus equals right-hand side dot y. And that's it. That's all we need to do. So if I rerun this again, our ball still works exactly as we expect. So this is a really cool feature of Rust that we can use, is these traits that allow us to basically do what we're used to with other type of math, but with custom types. And it's really amazing. And that is example 1.2, the bouncing ball with vectors. Thanks a lot, and I'll see you in the next video. Bye.